Hello, and welcome to Donaldson Clean Solutions webinar, What is Dirty Diesel Costing You? I am Jim Peterson, Sales Manager for the Donaldson Clean Solutions Group. Diesel is the lifeblood of many organizations. Without it, digging, hauling, planting, harvesting, powering, none of it is possible. Therefore, keeping diesel healthy is essential to operations. The range of hazards that can infect the integrity of diesel is diverse. Too often, however, customers do not understand this diversity or how it truly impacts the bottom line. Beyond the cost of ruined injectors, there are a host of other factors that need to be considered, and we want to explore these today. For the purposes of today's webinar, we will focus on three categories of contamination. First would be hard particulate, dust and dirt. The second is water, and the third is soft particulate, which we refer to as soft, sticky stuff. And this is really a whole host of issues that we're going to deal with as a single category. But let's start out with dirt. In many of the applications where diesel is consumed, dust and dirt are omnipresent. These substances are probably the first ones you picture when you think of contaminated fuel. Perhaps you've heard the phrase to dust an engine? Certainly most filters are designed with dirt as the foremost enemy. I want to mention that in North America, fuel is not excessively dirty. We often hear, "It's the responsibility of my fuel supplier to bring me clean fuel." The good news is, most do. It's just the goalposts have been moved regarding how clean the fuel needs to be. Additionally, once the fuel is in your tank, it is your responsibility to keep it clean as it goes into your vehicle's fuel system. Hard particulate causes several problems in the fuel system. Damage to moving parts leads to starting problems, poor engine performance, idling issues, and potentially complete engine failure. Also, the spray pattern generated by the high-pressure common rail injector is critical for proper combustion and overall fuel system performance. It must be extremely precise in terms of quantity, distribution, and timing. Ball seat valves are sealed with balls that are only 1 millimeter in diameter. A good seal is absolutely essential for proper injection. Damage from erosive wear, seen in this picture here highlighted by the red arrow, will cause overfueling, leading to decreased fuel efficiency, and eventually it can shut you down altogether. Pump performance can also be compromised by scoring and abrasive wear. These issues are magnified by the tighter tolerances and extreme pressures in high-pressure common rail engines. In these circumstances, it's the smallest particles, 1 to 5 microns in size, that cause the most damage, virtually sandblasting part surfaces. Calculating the cost of dirt on operations is going to be different from some of the other contaminants we talk about during this webinar. Dirt issues are likely the most catastrophic to equipment and impact operations, and they can have profound issues relating to warranty and total cost of ownership. According to David Barker of CAT, contaminated fuel can cause an unacceptable rate of injector wear and resultant failures, and as a result, unnecessary repair costs. When calculating simply the cost of repairs, injectors are expensive. Up to $16,000 to change a set of injectors on a haul truck, $4,000 or $5,000 for pumps and injectors on a diesel pickup truck. But of course, these are not the only costs associated with ruined injectors. Loss of production, mechanic resources, disruption to other equipment, this all adds to these costs. One mine cited costs up to $150,000 per hour due to unplanned downtime. But before the actual failure sets in, dollars are already flowing out of the till. As the spray pattern is altered, there's a fuel economy penalty. Consider, for a fleet consuming 10,000 gallons of fuel a day, just a 0.5% decrease in fuel economy can cost close to $55,000 per year. Now, I'm not trying to make the case that cleaner fuel will improve your fuel economy, but cleaner fuel will absolutely halt or slow the rate of decrease of your fuel economy. And this is an important point. So how have we gotten here? Only 10 years ago, particles in the 7 to 10 micron range were about as small as filters needed to worry about capturing. However, with high-pressure common rail engines, we are concerned with particles as small as 2 or 3 microns, and we need to keep as many of these particles out of the fuel system as possible. This chart helps to show how the filter efficiency requirements have evolved. The blue line shows the filter efficiency of a typical filter found at the bulk storage tank. We often refer to these as maybe a 30 micron filter. And at 20 microns, this filter has an efficiency of about 96%, or it stops 96% of particles 20 microns in size. As the particles get smaller, the efficiency goes down, and at 3 and 4 microns, we have 40 or 50% efficiency. Now in the past, fuel injectors could handle the very small particles, so fuel filters were designed to stop particles in the 7 to 10 micron range. The green line shows how the efficiency of these filters varies with particle size. 10 micron sized particles are stopped around 99% of the time. 3 micron sized particles are only stopped about 82% of the time. With high pressure common rail injectors, we need to stop particles down to 2 or 3 microns in size. This means the filters need to be extremely efficient on even the smallest particles. As you can see with the red line, today's modern fuel filters need to stop just about everything, and it's worth noting that the vast majority of particles are small, smaller than 2, 3, 4 microns in size, so the filters have to capture more and more particulate. Now, purely from a filtration standpoint, dirt is really the easiest contaminant to deal with. Filters are designed to deal with dirt and able to do it quite well. And historically, filters did not plug up due to dirt. They would go from maintenance period to maintenance period, being changed when convenience for operations. More complex engines now require filters to capture smaller and smaller particles. And because there are so many more small particles than large ones, we now see filters plugging up before meeting desired service intervals. And this will increase costs, an extra $20 or $30 each time a filter needs to be changed. Proper filtration at the bulk storage tank will eliminate the vast majority of hard particulate related issues, and in most cases should cost less than 0.5 cents per gallon. Water is the most vital substance on Earth, unless you happen to make your livelihood with a combustion engine. Then water can be quite the source of pain, seeping into underground tanks, appearing seemingly from nowhere when temperatures drop, eating away at vital components anytime it can. Simply put, water may be the most significant barrier in the struggle for the best fuel performance. Water causes damage to both fuel tanks and engine parts. Rust and corrosion in the tank create hard particulate that is passed along in the fuel, causing engine wear. Component life is also shortened by, for example, abrasion. Water has lower viscosity than diesel, therefore providing less of a lubricating cushion between the opposing surfaces of the moving parts, and this leads to increased abrasive wear. Other things such as etching, pitting and cavitation, spalling, and even ice. Free water and fuel can freeze, causing ice crystals that behave just like any other hard particulate, plugging up filters, causing wear. And one of the challenges, of course, with ice is, by the time we get the equipment to the lab for our investigation, the ice is long gone. Purely from a filtration standpoint, many of the costs associated with water and diesel fuel will be similar to what we discussed relating to dirt. Ruined injectors, ruined fuel pumps, water will devastate these components. In addition, water will wreak havoc on the infrastructure, corroding pipes and tanks. Really though, calculating the costs of water gets more complicated in a hurry. Water is a catalyst for many of the problems we will discuss in the next section. Microbes, bugs, require water to live, thrive, and survive. Excessive water and fuel can cause additives to react in unexpected ways. There will be water in your diesel. However, minimizing the water above saturation point will really help you achieve more, not just through improved equipment life and performance, but by bringing down the number of fuel headaches you will experience. Unfortunately, the advent of ultra-low sulfur diesel has made the fight against water more difficult. Traditionally, fuel water separators on board engines and coalescers at the bulk storage tank were used to prevent free water from reaching critical components. Frustratingly, these technologies do not work as well due to how ultra-low sulfur diesel interacts with the coalescing filter media. The sulfur in the fuel had purpose, including ensuring lubricity. When this sulfur was removed, it was replaced with surfactants. Unfortunately, these surfactants do not react the same way with the filter media, and water removal has suffered. We will cover this in more detail in our next webinar. However, for our purposes, the fact that coalescing is not as effective means we need to look at different methods for dealing with water. The fight against water is really about handling practices. The best approach for dealing with water in diesel fuel in 2015 is to prevent the water, as far as possible, from reaching critical components. Donaldson recommends a two-tier strategy for accomplishing this. First, keep ambient moisture out of the tank through the use of a tank breather filter, such as shown in the filter on the left. These style filters can greatly reduce the amount of moisture introduced into the tank through the vent and will greatly reduce condensation. These systems can cost as little as $300 per tank and will need to be serviced periodically. We also want to prevent free water, which is water above the fuel's natural saturation level, from passing into the equipment. Filters with absorbent media can take care of this. Filters such as this have a finite ability to hold water and will need to be serviced when plugged up. And the more water that's in the fuel, the more filters it will take to keep the water out of vital equipment. Additionally, tanks should have a drain on the ideally slanted bottom to allow water to be drained from the fuel. Some companies with very large tanks will use floating suction to draw fuel from above instead of below. Again, our next webinar in April will deal with the complexities of removing water from diesel. After tackling dirt and water in the fuel, we need to deal with a category of contamination that is much more unpredictable. For the sake of brevity, it is to our advantage to lump a whole group of things into one category of soft, sticky stuff. And this would include such things as glycerin issues in bio, fuel additive issues, and microbial growth. Each of these is worthy of their own webinar, and these will be covered at a later date. But for today, we will treat them as a collective group due to the fact that, generally speaking, they cause similar sorts of problems to fuel systems. One common symptom of soft, sticky stuff is a rapidly plugged filter. Filters either on a vehicle or at the bulk storage tank that are fully clogged in a very short period of time. This kind of plugging can have a significant impact on operations, as vehicles will be halted unexpectedly. Now, in some cases, it's very easy to see what is happening, and I've got some pictures here that show this. These filters were plugged up very, very rapidly with some sort of problem in the fuel, and it's obvious that nothing's going to get through them. However, some filters that are experiencing these issues will not have any visible signs of plugging. In fact, it is often a good clue that a filter that still looks new is stopping some sort of additive problem from moving downstream. Filters that are plugged with dirt or other hard contaminant will have obvious signs such as black or other discolored filter media. But in the case of the filter shown here, the media still looks brand new, and it's because it was plugged with an additive issue in the fuel. Now keep in mind that proper additives in the fuel are critical for performance. However, in some instances, factors such as excessive water, cold weather, these can lead to unexpected reactions leading to rapid filter plugging. Let's take a look. At 2,500 times magnification, we can see that this filter is starting to plug up. In fact, the only places now for fuel to keep flowing through the filter are highlighted by the red circles. And after only 30 minutes, the filter is completely plugged, and there's no way for fuel to get through the filter media, and the equipment will stop running. Now, on a vehicle-by-vehicle basis, the cost of soft, sticky stuff is considerably less than the water and the dirt. Switch out the plugged filter and you're good to go. Perhaps at less than $100 for a new filter in a mechanic's time. But unfortunately, life is not that simple. Rapid filter plugging is very contagious. Whereas dirt in the fuel might cause one vehicle to fail in an untimely manner, soft, sticky stuff can bring an entire fleet to a dead stop. Consider if you have a 10,000-gallon tank of fuel filling garbage trucks. One cold morning, that tank experiences some sort of fuel problem. One truck after another is stopped dead by the side of the road. Tows have to go out, mechanics get backed up, the garbage goes uncollected, and chaos quickly ensues. And the costs of this can quickly run into thousands and tens of thousands of dollars. Changing fuel technology, as well as the evolving engine technology and corresponding filter efficiency changes, as discussed in the dirt section, have led to a significant increase in the incidences of rapidly plugged filters. There's a couple of reasons for this perfect storm. The higher efficiency requirements mean that, simply put, more is captured. Problems that in the past would have passed through are now being captured by the high efficiency filters. This includes both dirt as well as some of the issues we run into with additives. Additionally, government mandated fuel changes have led to more biodiesel being used and many different additives being used to replace the characteristics of the sulfur. Again, there's many important reasons that these products are included in the diesel. However, like anything, in the wrong conditions, problems occur that can manifest themselves through rapid filter plugging. It's important to remember, many fuel additives as well as properly blended biodiesel are not contaminants. And I want to stress it's not the intention of this webinar to make that claim. We reference in this slide a perfect storm, and for the end user and all of the companies supporting them, these are challenging times. And Donaldson is proud to partner with many companies, such as fuel suppliers, additive manufacturers, and others, to ensure that diesel users can weather this storm as well as possible. High efficiency filtration is still vital in keeping engines running. Removing high efficiency filtration in the face of rapidly plugging filters is not going to be the answer in most cases. Taking care of these various issues requires zeroing in on the actual problem. We're going to talk more about that process in just a moment. The ultimate solution, however, is going to be dependent upon the problem. If microbial growth is causing the issue, a thorough cleaning of the tank with biocides will be in order. A thorough tank cleaning can cost $4,000 or more. Simply hiring someone to come out and kidney loop contaminated fuel can run well over $1,000, plus the need to have additional storage for that fuel. If it's an additive issue, then a different blend of additives or fuels will be what the doctor ordered. There are costs associated with this as well. For example, to deal with cold weather plugging issues, which we addressed in our previous webinar, many customers use a blend of number 1 diesel instead of number 2. However, number 1 diesel costs more than number 2, so the fuel costs go up. On the other hand, when taking into account the lost time and productivity of down equipment and rapidly plugging filters, these costs may be quickly made up. It is important to understand what is plugging your filters. Often, when I visit with customers, they blame some vague bio problem, or we think we have an algae problem. Just as with a medical diagnosis, solving the wrong problem won't help and may exacerbate the existing issues. One example that we frequently deal with is the misapplication of cold flow improvers. As the weather gets colder and colder, customers' filters plug up. The customer then, understandably but mistakenly, adds more and more cold flow improver, which in actuality causes filters to plug up even more rapidly. For customers who are having injector failures due to dirt, cleaning the tank is only a partial solution. Kind of like washing your kids' play clothes right after they come in and then sending them out with new clothes. The kid clothes just get dirty again. Putting a new diesel into your clean tank will just start the process of contamination over. A better option might be filtration on the bulk storage tank to keep the dirt out of the equipment in the first place. To assist with the process of determining what exactly is causing the filter plugging, Donaldson is pleased to announce our new filter forensics program. Using our state-of-the-art labs, filter forensics will help customers determine what is plugging the filters so the proper course of action can be plotted. We will do visual inspections, chemical analysis, and scanning electron microscope analysis to determine the chemical and physical makeup of whatever substances are plugging up the filters. Once the cause of the filter plugging is known, all of the vested parties can be a part of the solution. Filter suppliers, fuel suppliers, additive suppliers, maintenance, reliability, purchasing can all come together to get you running again. Whether it's $15,000 for a new set of injectors, a daily fine for missing a vital deadline, $30 for the next set of fuel filters, or a half a cent a gallon for bulk filtration, without question, dirty diesel costs money. And in some cases, the cost of dirty diesel can't even be expressed monetarily. Understanding these costs is an important part of designing a contamination control strategy. Understanding these costs reminds us how critical it is to accurately diagnose and address fuel issues when they occur. Business always involves cost trade-offs. We hope this webinar shines some light for you on the costs associated with dirty diesel, as well as some of the costs involved with cleaning diesel up. Burning the cleanest and driest possible diesel in your equipment will save money and ensure that you achieve more. Thank you for taking the time to listen to this webinar. We hope you found it to be interesting and informational. We invite you to check us out at mycleandiesel.com, your online resource for all things diesel, and connect with us there to stay up to date with the latest the industry has. You can also check out old webinars and register for new webinars. Sign-ups will start soon for our next webinar, which will be April 23rd and 24th, and will deal with the complexities of removing water from diesel fuel. Thank you.